So cool guys, today we are going to discuss the Codeforces around 860 that was rated for Dev 2. We'll be discussing the first four problems A, B, C, and D. So let's get started with the problem A. The problem A is showstopper. The problem states that you are given two arrays A and B. In one operation, you can choose any integer I from 1 to n and swap the numbers in A and Bi. And you are allowed to perform any number of operations as you require. After that, what the thing that should hold is that the last element, or an, that is the last element of A, should be the maximum amongst all the elements of A, and Bn, that is the last element of B, should be the maximum amongst all the elements of B, right? So this is what we need to do, and at the end we need not tell them the arrays that we have constructed or what we have done. We just need to tell them if it's possible to do this, do these operations and get this result or not. So this is a very easy question. I don't think it requires much explanation. The simple thing you had to do over here is that you had to make one array minimum and other array maximum, right? Because if you are saying that this array is minimum now, so let's say if AI is less than BI, then it's fine. If your A1 or AI was greater than BI, then let's say you swap it. So if you do that for all the indices, then your array A would become minimum, right? And as soon as your array A would become minimum, its last element should technically be greater than all the elements. If that is not happening, then your answer does not exist, right? So for example, over here, you will say that, okay, 7 and 7 are equal, so no worries, but 9 and 6 is lesser. So let's move it over here. So it will become 7, 6 now, right? 9 would come over here. Then you'll say that, okay, 7 is lesser, 9 is greater, that's fine. So first array would become 7, 6, 7, and the other next array would become 7, 9, 7, 9, 9. So that's gonna work. And similarly, you're gonna perform the same thing for all the arrays. Now, since most of you have already done this problem A, I'm not discussing this in detail, but let's just look at the code a bit. Okay, so here's the code. So firstly, we are taking the arrays, and then I'm checking that if my array A, so over here I'm doing the opposite. You can do the opposite if you want. Okay. Over here, I'm making my array A maximum and B minimum. So I'm saying if my array A's value is less than Bi, then swap it, right? And then I'm checking that for all the values, right? Since I've done it for all the indices, then all the indices I, which are less than n, or you can say less than n minus 1, that doesn't matter over here. So which are all the valid indices of A should have a value that is lesser than the last value. If they have a value that is greater than the last value, in that case you have to print a no. I hope this code is simple and there are no doubts in it. If there are, you can let me know. We'll wait a second for you guys to speak. Okay, cool. Gonna move to the next question now. Okay, so the next question is problem B. Is there anyone who faced some difficulties in this problem? I hope everyone was able to solve this. So the problem is pretty simple. The problem states that lottery 3 sevens was held for m days. On the day I, n people participate in it, and it is known that each of the m days only one winner was selected, right? The lottery winner on the day I was not allowed to participate in the lottery in the days from I plus 1 to m. So if a person already wins on a certain day, he won't be able to participate further. So naturally he won't be able to even win further, right? So that is a constraint. And then they have just described how they're providing the input. So in the input, firstly they'll mention the test cases, then the number of days for which the lottery is played. Then for each of these days, they'll provide you with two values, that how many players actually played and what are the values of the players which played. So they said that, okay, 3 days this lottery was played. On the first day, 4 players played. That were 1, 2, 4 and 8. On the second day, 3 players played, 2, 9 and 1. And on the third day, 2 players played, 1 and 4. Now what they want you to tell is that what is a possible permutation or what is the possible answers of the players who won. So you can say that, okay, can you say that 2 won over here? You can't say that because 2 actually won on the day second as well, right? Oh, sorry, 2 actually played on the day second as well. So it cannot be the case that 2 won over here. Had 2 won over here, then he wouldn't have played over here itself. Now, in the other scenario, let's say we say that 8 won over here. That can be true because 8 is not happening anytime later. That is fine. We can say that 4 1 over here. No, we can't say because 4 is actually occurring later also. So this is the entire thing you need to do. Now order of n square approach is pretty obvious. You can check for all the elements. You can check that when this element is occurring last, but that is a waste of time and even would give you a TLE. a better approach would have been to traverse it upside down, right? So what I can say is that whenever a element is occurring, right? So let's say over here, I'll say that okay, 4 and 1 are occurring, right? So I can say either 4 1 or 1 1, because after this no contests are happening, so both are valid candidates for winning the lottery, right? And when I'll come over here, so since I'm traversing, okay, let me just explain this a bit so that, okay, give me a second. Yeah. Okay, so what I'm saying is that since you're traversing from the last to the first, so you already know that at this place, let's say 1 and 4 played, right? So you can say out of 1 and 4, anyone won. So one of these actually won the lottery. So let's say 4 won the lottery. Cool. After that, you'll reach to your second day. This was the third day and this was the first day, right? To your second day, you'll see some values. So the values you'll be seeing is 2, 9 and 1, right? So you'll see on the second day, 2, 9 and 1 played the match. So this is cool enough. So 1 cannot be the winner because I've already seen 1, right? Now in order to store it, you can use an unordered set. You can use anything you want. I'll not be going into the data structure details. So you can say 1 cannot be the answer, but the remaining 2 can be the answers because they are not playing at any day after this. Similarly, you store 2 and 9 to your unordered set after printing the result, and then you'll come to 1 and then you'll repeat the same. So the code is also pretty small and simple. In the code, I'm firstly taking the values, right? After that, I'm taking I'm taking a set that is seen, and then I'm initializing the value of my result array, and I'm initializing all these values to -1. That is a dummy value for me. After that, I'm traversing it from right to left. So on regular basis, we actually traverse an array from left to right. Over here, I'll be traversing it from right to left. I'll be checking if for this particular element, if the value is already seen. If it's not seen, then what can happen? If it's not seen, then this is a potential candidate for winning, right? So I'll store that value in my result. So I'll say, okay, on this particular day or on the day I. So this I basically means the day, right? So on day I, E was the winner. I'll store that and then I'll mark it to my scene. After that, what I have to do is that in case any of these values are still -1, that means I was not able to find a candidate winner or a potential winner for that particular day. So I'll check if any of the value is still -1. So I'll just count the values of values in result. So if any of these values is -1 or the count of -1 is greater than 0, in that case, print -1 and return. If that's not the case, then you can print the entire array. I hope that makes sense. Any doubts in this? Okay, cool. Okay, let's move ahead to problem C. Problem C is an interesting one. So problem C states that the store sells n types of candies with numbers 1 to n one day. So there's actually a lot of gibberish. I'll just just give you the gist of it, and let's just look at the constraint and get started with the problem. I hope that you have already gone through the problem since you are already here. So then they have given the constraints and stuff, but let's just understand what the question wants us to do. So what the problem wants us to do is that you'll be given two arrays, right? This would be array A. This would be array B. Now you can let's say all the divisors of A are D. Let's say, so we can have any D. So D0, D1, D2. These are all divisors of D, right? Now you can do B into D0, B into Di. So you can take any D from this, right? So Bi is given. So at any index I, and let's call this Dj so as to avoid confusion. So at any index I, you'll be having two numbers, that is Ai and Bi. Corresponding to this Ai, you'll be having several divisors. So let's call them Bij, right? So these are the divisors of Ai. Then if you multiply Bi into the divisor of Ai, which we have currently taken, so we can take any divisor. So let's say we took some divisor. Let's call this divisor as D or Di, right? Then you take this value. Then you move to the next one, right? Next index. If you're able to construct the same value over here also, right? So let's say over here you constructed some value a bi di, and this is bi plus 1 into di plus 1, right? Now if your bi di is equal, then you need not put, or you need not increase your score. If they're not equal, then you need to increase your score, right? So if these are equal, then you can actually move ahead, and then also you will check that, okay, if the value is equal to bi plus 2 into di plus 2, if this value is equal, well and good, else you need to increase your score. Now your final goal is to minimize the score itself. Now let's look at some observations over here. So the very first observation is, since I want to minimize my score, then it's always beneficial for me if I could set this particular value to this value, right? If I can set the value of bi plus 1 into di plus 1 equal to bi di, in that case my score is going to decrease, right? And that's what I want. So I don't want to assign new values every time. I want to select, and what are the variables I can do? So bi is actually a fixed value, right? So we cannot change bi. The only control we actually have is on di itself. So since di is all the divisors of ai, so we can only change di, and that's what we are gonna do. So let's say, let's consider that for the first scenario we don't have any control, right? So for the first scenario we'll definitely have to have a score equal to 1, right? So we'll say that firstly we took a number over here which had two variables ai and bi. Now it has many factors that are di, but let's say we just took ai. So a number becomes ai into bi, right? But what if I took the lowest divisor of these? So what was the lowest divisor? The lowest divisor of any number is obviously 1, right? That would give me simply ai, right? Then I'll move to the next element. I'll move to ai plus 1 into bi plus 1, right? Now I'll say that what is the max value I can get from you? So he'll say that, okay, the max value you can get is actually ai plus 1 into bi plus 1. Cool. But now he also says, what is the minimum value you can give me? So the minimum value would be bi plus 1, considering that ai plus 1 is going to be 1 itself, right? Now he'll say, okay, so yeah, it got inverted actually. No, it's fine. Okay. Now we'll say that previously you were having this value, right? Previously, this is the value you were having. Right now you are having this value. But what is the guarantee that these two values would be same? Or let's say we select any value for that matter over here. So we select any d, right? And that value should have a similar, should be equal to the value we are carrying on from the previous end. So what's that guarantee? So let's look at the code, that how we can guarantee that particular thing. I'll definitely come back to this explanation, but let's look at the code. So we are doing exactly over here. So the upper value we are having is a naught into b naught, as I told you. So a naught is actually the first index considering zero base indexing, and then value of lower is b naught, because b naught is something we cannot avoid. B naught we have to take. We can take like a naught as 1, and so we can get a value of this. But b naught we cannot avoid. So b naught is going to be there. And initially we already said that we are going to use this value. So answer is 1. Then for all the values, I'll say that, let's say you already considered the previous value that was upper, right? Now what is the max value you can give me? So the max value it can give you is ai bi, right? ai into bi. You'll say, let's take a GCD of it. Now why do we want to take a GCD for this? So GCD would give you the greatest common divisor, right? Okay, that would come in handy. Now why would that come in handy, and why are we even doing that? So if you look over here, then we are calculating the LCM. Now we are calculating the LCM for the previous lower value that we were having and the current lower value. Now even if GCD didn't make sense to you, this definitely would make sense, because, okay, let me get back over here. Okay, because the thing is that these are the values you cannot ignore. So if you want both of these values as collectively to be in the same set or to have the similar values, then definitely whatever value you take for ai, or whatever value you take for di, and whatever value you take for di plus 1 should be such that when they multiply each other, right? So when they multiply it by vi and they multiply by bi plus 1, they should become equal. Okay, LCM. Now, what when would this happen that they become equal? This case would only arise. Okay, so yeah, this case would only arise when the value of when the LCM of bi and bi plus 1, right, is also a divisor of this, right? It's all this value should actually be a divisor of this total value, right? Because bi and bi plus 1 are two terms that are always going to be there. So your term can be anything, but bi and bi plus 1 are always going to be contained. So we are just taking the LCM of both of these, because LCM basically is the lowest common multiple, right? So this term is definitely going to be a divisor of this term. So that we took, and then we checked that whatever the upper value we were getting. So you were saying that okay, this is the value I can take at max, right? So we took that value, and we already told that why we took that value, but you didn't understand that what is the benefit of it, right? So if this value upper is divisible completely by lower, now checking if a value is completely divisible is easily done by taking the modulus operation, right? So if this value is completely divisible, in that case we can say that okay, there is some value which can value for ti which can get me the same value as previous one, right? But in case this doesn't happen, so let's say your value was not equal, in that case you would say that okay, I'm not even getting the particular LCM, so it's not possible for me to proceed ahead. What would I do in that case? So I'll say okay, the set actually stops over here. So set gets completed, right? Once your set gets completed over here itself, you'll say that your upper needs to be refreshed now, because the set is already completed. Now you need to start a new set, or you need to start new values now. So your upper would now again be initialized to this value, right? And a lower would also be initialized to value that you cannot ignore. So bi is the value that you cannot ignore, and then you'll say that okay, I'm starting a new set. So let's call this let's increment the value of answer or the answer, and then you'll print the answer itself. Let's check the code. Yep, it works. So I think a few of you might have doubts in this. Any doubts? All good. Okay. Can you explain GCD? Uh, I didn't get your point, bro. If your mic is up, please speak up. Else let me just think what you're saying. Okay, cool. So you know GCD, right? That's the greatest common divisor. So that's what it is. It's an internal implementation of it. Underscore GCD is the internal implementation of it. You can actually define it and call it GCD itself, because underscore is required if you are using the internal implementation. Sharon, you still have a doubt? Sharon, what I'll do is I'll take your doubts at the end, maybe, because your mic is not on and the video is gonna get long if I proceed in this way. Cool. So with this question is also done. Let's look at problem D. Okay, not B but D. Okay, so the problem states that you are given an array a1, a2, a3 up to so on to an, consisting of integers that a1 plus a2 plus up to so on to an is equal to 0. This is a very, very crucial observation which I actually missed. Cool. And it took me a lot of time then to construct the solution. Then they say that you have to rearrange the elements of the array A so that the following holds true. So maximum of any subarray of this. Now when they say that maximum of modulus of this, so basically they are saying that your L and R can be anything that should be within the range of the array, right? And when you add these things up, you have to take the modulus. So let's say you're getting a value that is minus 100, so you'll consider it 100. Not modulus but absolute value. So you'll be taking absolute value. So your negative value will become positive. Should be less than maximum value minus the minimum value of the entire array. So over here, although over here we are considering subarrays, over here we are considering the entire arrays, right? Or entire array, right? Okay, then they say that, okay, yeah, this is gibberish. So what they expect us to do is that we need to permute the elements. So permutation basically means we cannot delete or add any other element. We just have to take those elements and rearrange them. After rearranging these elements, the thing that needs to hold is this. Cool enough. Now the first thing, or I'll say the only important observation, is that would the answer always exist? How would we even prove that the answer always exists? So let's just say when the answer does not exist, when would that happen? So we are told that I don't want to write it as the mathematical equation they gave us, so let's write it in a better, easier way. So basically maximum of all subarrays, or sorry, not maximum of all subarrays, but yeah, maximum sum of absolute, okay, maximum absolute sum of all subarrays. So that is what they wanted to say, right? Needs to be less than your maximum of array minus minimum of array, right? Now the thing over here is it's not less than equal to, it's strictly less than, right? Now what if I provide you with the array of all zeros? What would happen in that case? In that case, the maximum and the minimum of the array is 0 itself, right? So you'll say this value becomes 0, and no matter what you take over here, you are also going to get a 0. So 0 is less than 0. No, it's not. So in this case, wherein you have all the zeros, you're going to get answer no. And we can prove it that the answer exists in all the other scenarios. Now, how can I even say that the answer exists in all the other scenarios? Because they said that a1 plus a2 up to so on to an, right? This actually is 0. So what I can do is, as soon as the subarray sum becomes negative, right? Or as soon as my array sum starts becoming negative, I can add a positive value to it, right? So if my pre-sum starts becoming negative, I'll add something positive to it, right? Or if the pre-sum now is not negative, it's greater than 0, then I'll add a negative value to it. If I keep doing this, so the value of my array would keep deviating between positives and the negatives, right? It will keep dodging like this, right? If this keep dodging like this, then never ever, okay, let me just give you maybe a more virtual, like visual proof for this, because the proof is actually more intuitive, but let's try to understand the more visual proof for this. So I'm saying that this is the value that you had, right? So let's say you started with this particular value itself. We are able to construct any array. Let's say we started with the maximum value we had. So this was the point, and let's say this is the number line, or this is basically your 0 axis, right? So you said, okay, currently I'm having this much. Then you'll say, what is the pre-sum? You'll say, okay, it's max. So you'll say, okay, cool, let's add some negative to it. Now let's say it drops down over here, right? Added some negative elements. So it dropped down over here. Then you said, okay, it become negative. So let's make it positive. Let's make it negative, then positive. It will keep going like this, right? Cool enough, but your intention was actually to keep it lower than max minus min, right? So how do we assure that it lies within this particular range? We can say that because whenever you do a maximum minus minimum, over here your maximum is always positive, your minimum is always negative. So its collective value would actually be greater than absolute of max and absolute of min. Just to give example, let's say your value was 4, 3, 2, 1, minus 1, minus 3, something like this, right? So your minus 3, 4, minus 3, that becomes 4 plus 7, 4 plus 3, that is 7, right? So this value 7 is greater than 4, right? And this value would also be greater than 3 taken modulus. So taken absolute value. So absolute value of minus 3 is 3. It would be always greater than this. This is pretty intuitive. I don't think there's anything to explain over here, right? But I hope that this graph representation makes it clear. Now, whenever you're doing this, so your max minus min actually would be having a value somewhere over here, right? And your max minus min would be having a value over here. That is the absolute value in negative. But you'll always keep trending in this particular range. You'll never actually hit it. That makes sense? Guys, any Any problem in this explanation? Cool. Okay, cool. I'm gonna explain the solution. The solution is actually easy. Okay, so firstly we'll be taking two arrays, positive and negatives, right? And then I'm taking two numbers, x and y. You can take positive sum. Oh, sorry, these are actually the pointers. So pointers, or you can say indices to positive and neg sums, negative arrays. Cool. Then you'll say that, okay, so firstly you already checked that if your count is equal to n, if your count of zeros is equal to n, that means all the elements are zero. This is the only case where your answer does not exist. We already talked about it, right? Then you say that your okay, then you say that push all the positive numbers into the positive array, push all the negative number into the negative arrays, your sum is zero. And at each step what you do is, if your sum is less than equal to 0, you add the positive element to it. If your sum is greater than or equal to 0, right, or if it's greater than 0, you add the negative element to it, right? Each time keep increasing the indices also, and keep printing the result on the go itself. At the end you just print /n. So this is the working code for this. Let's just submit it. Okay, it's running. Let's just submit this. Yep, submitted, accepted. Cool guys, so yeah, that was it for the session. I hope this explanation is clear. JavaScript, you have some doubt? And guys, it's a humble request, whenever you are in the session, try that your mic is on, right, so that it's easy for us to interact. C giving wrong answer, mine is giving correct answer, bro. Okay, like you have some doubt with your problem. Yeah, cool. I'll just turn off this recording and then we can discuss that.